Performing HTTP requests is all fun and games until there is no internet connection. Sure, you can display a sad error message or a Chrome dinosaur to the user, but wouldn't it be better to take the initiative and automatically retry the request when the user connects to a Wi-Fi network or enables mobile data? This is precisely what we are going to implement in this tutorial. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to build a very simple app which will be able to request data from a very simple JSON placeholder API. And it all works very nicely when there is some sort of an internet connection. However, when we disable internet and then request data, what's going to happen is that we are not going to get any error message popping up on us. Instead, we are going to schedule a retry of the request, and whenever internet connection comes back, we're automatically going to retry the request, and the user doesn't have to do anything like pressing a retry button. Everything is going to be handled for the user. We're going to accomplish this with Dio and also the connectivity package. And actually, this is the starter project, which is prepared for you together with all of the packages already present in the pubspec.yaml. So that's Dio and connectivity. And if you want to get this starter project with this very nice looking UI already done for you, be sure to check out the written tutorial from the link in the video description, because there is the starter project, and also over there you can go through this lesson at your own pace, get all of the code rewrite over here, and really just take a look through this lesson on your terms. So let's get going. We are going to use the Dio package and not the sort of default HTTP package to perform the requests. That's because Dio supports interceptors, and that's precisely what we need because we want to intercept any errors which occur during the request. Actually, when I run this app, which is coming from the starter project, which simply just calls Dio get and some sort of a JSON placeholder posts, and we get the first title of the post. It's very simple what we are doing here. When I run this, the UI looks exactly the same as that of the already finished app, but what happens is that when we request data with internet connection disabled, we are going to get a socket exception. And if we come back to the app, well, we still see this circle spinning, but when we enable internet, the request is not going to get retried automatically. So we just got socket exception, we didn't even handle it, and yeah, retry does not happen. That's because we need to add an interceptor to this Dio client, which will intercept all of the errors for us and retry the request on user's behalf. So let's create that interceptor, shall we? We're going to create a new folder called Interceptor, and let's just create a new file under there. It's gonna be called Retry Interceptor.dart. And you really do not need to know much about Dio. We are not getting deep into it. We are just going to focus on interceptors. So even if you have no previous Dio experience, you're going to be good to go with this tutorial. So in order to create an interceptor with Dio, we're gonna create a simple class, retry on connection change interceptor. It's going to extend interceptor. which comes from dio. And interceptors intercept every possible thing which goes on in the dio client. And they do it with callback methods. If we go into the interceptor class definition, we see that we can override on request, on response, and on error callbacks. And of course, because we are really just trying to know when the socket exception happens, which indicates that there is no internet connection currently, we really just want to override the on error callback because we are interested in errors after all. So let's override on error, which will grant us a dio error. And for now, we're just gonna leave this thing empty. We actually do not need to call the super classes on error method. And you may think that right inside this on error callback, as it is looking now, we can start using the connectivity package, right? Something like this, and use the on connectivity change stream, which updates whenever the user connects or disconnects from a mobile data network or from a Wi-Fi network and so on. Well, no, that's not true. We cannot just straight up start scheduling the retry of a request right here. That's because this on error callback will run indiscriminately for every single possible error which may occur when performing a request. This includes errors coming back from the server, such as 404 not found or 401 unauthenticated, I think, and so many things which can go wrong on the server. And we want this interceptor's on error callback to run only specifically for when a socket exception occurs. So we need to have a way to find out if this dio error, which is passed into the callback, actually represents a socket exception. For it, we're gonna create a bool returning method should retry. It's gonna be private, and it's going to accept dio error. Let's call it error also, and from it we're going to simply return that we should retry if error type is equal to dio error type, which is an enum, right? So dio error type dot default, and as you can see in the documentation, default means some other error, and some other error includes errors which come back from the system, for example, the socket exception. And also, if the error is not null, and lastly also, error is a socket exception. Cool. We just need to check if error is not null, because possibly it can happen that error is null, and we definitely do not want to cause a null pointer exception when we are checking for the socket exception. That would be catastrophic. So what we want to do now is simply check if we should retry for the error. Then we're going to perform the scheduling of the request whenever the connectivity status changes back to being connected. And otherwise, if we should not retry, what we're gonna do is that we're gonna return the error simply back unchanged. And for some reason, yeah, we need to make this function asynchronous. That's kind of obvious. And with this done, whenever we should not retry, the error, which does not interest us, is going to be returned from this callback, and that will simply push it to the caller of the get method, for example, or the post method. So we do not need to actually add an else statement here, because but we can, but we don't need to, because we are actually going to return something from this if statement also. Right, let's keep this terse. And now let's go on to implementing the request retryer, because having the interceptor is only one part of the game. That's because we need to use the connectivity package, as I've already outlined briefly, and use the onConnectivity change stream, listen to it, and whenever the connectivity changed to be connected, we're going to retry the request. However, I do not really like to put multiple functionalities into just one class. We want to follow the single responsibility principle. So we are now going to put this connectivity logic right over to this interceptor. Instead, we are going to create a new file and a new class for it. And it's going to be called Dio Connectivity Request Retryer. So let's create one such file right here under the interceptor folder, Dio Connectivity Request Retryer .dart, and we're going to create class file. I have these kinds of shortcuts in place, so we have just created a class Dio Connectivity Request Retryer, and what are going to be its dependencies? Well, we definitely need to have a Dio client present here so that we can perform the request one more time. We are basically going to do something similar as calling dio.get, but for the second time we are going to retry that request. So final Dio is one dependency. Let's import it, and the second dependency is of course the connectivity class, and let's just call it connectivity, and we're going to create a constructor for it, and let's also make these required. So we're going to use the magic of Dart formatter required, and let's just import whatever Flutter foundation for the required annotation. And now this class will have only one method, and that is going to be schedule request retry, which is going to return a future response. This response is the very response which also comes out of the regular get call on the Dio client. So we are really just returning an HTTP response, which is going to be retried in this retryer class. So this method will be called schedule request retry, of course with lowercase e, and it needs to accept some sort of an object which represents the failed request, right? Because this interceptor will intercept any sort of an error which goes on whenever we request something. So how can we actually get the failed request, and what is its type? Well, we can take a look. The error object actually holds a very handy field, request, which represents the failed request, and this is of type request options. So this means that our request retryer needs to take in request options, and is also going to be async. Cool. Now comes the time to finally use the stream which I have been talking about so much. So that's gonna be the onConnectivity change stream, and we want to listen to it, and it's going to pass us a connectivity result. And in this closure, in this callback, we are going to perform the retry logic. So what can we do here? Well, first of all, we want to retry the request only when the connectivity changes to be connected. So this connectivity result which is passed here is of type connectivity result, which is actually an enum. So we can check if connectivity result is connectivity result dot none, or should we say is not. So basically, if connectivity result is not none, which means that we are not disconnected, I know double negatives, but whatever. So it means when we are connected, only then we want to retry the request. Cool, so how can we retry the request? Well, we can call dio, and over in the UI, we are calling dio.get to perform a get request, right? We want to get something. But this would make this retryer only work with get requests. But what if we want to actually retry a post request or a patch request? Well, that would not work all that great. That's why we are not going to call get. Instead, we are just going to call request, and we are going to paste all of the methods like get, put, post, and all of that from our request options object, which holds every single data which is useful for the request, which we want to retry here. So first we want to specify the path for the request. We're going to say request options.path. And then we want to populate all of the other named parameters which are present on this request method. And actually, I'm just going to copy them from the written tutorial, and you can do the same because, yeah, as you can see, there's just a lot of them here. So we want to copy over the cancel token data and all of that other stuff, and we get everything from the request options, which are the request options of the failed request, which we now want to retry. Okay, so we are calling dio.request, but something doesn't play right here. We are not returning any response from our schedule request retry method. Actually, we are not returning anything from this method, and we surely do want to return this response. But we cannot do that because we are inside a closure, and the closure is inside a listen callback, which is of type void. So we cannot really put a return statement straight out to this closure. We need to create some other way to get this result of the request out from the schedule request retry method. So if we cannot straight out return something from a closure, what can we do? Well, we can use a completer. Completers are very useful for making synchronous code asynchronous, and also for occasions like this where you have a closure and you want to return something from outside the closure. So we are going to create final response completer. It's going to be of type completer response. And let's import Dart async in order to have this completer class here. And completers are very simple. All they do is that they can be completed, of course, and they can be completed with some sort of a future. So we're gonna go into here, into this closure, and write response completer dot complete with the dio request call. And as you can see, the complete method takes a future or already completed value of type response. And what this will do is that whenever we come here into this closure, whenever the unconnectivity changed stream emits a new value, and that value says that we are already connected to some sort of a network, our completer's future will complete, and therefore when we await the future somewhere in the UI or wherever, we are going to do what the futures do whenever the future completes. The await block will return a regular value, and we're going to continue with the execution of the code as if it were synchronous. So now the last thing we need to do in order to make this all happen is to actually return the completer's future from the method. Cool. With this done, we might think that we have just implemented everything we need to make this work. Of course, after we return it, that's kind of obvious. But actually, there is still one more thing we can do in this request retryer class. That's because if you take a look at this, whenever we schedule request retry, this runs, this closure gets created, and actually we would retry the request indefinitely whenever the connectivity status changes from connected to not connected and then back to connected. So because we definitely do not want to retry the request multiple times, but only the first time we get connected after being disconnected, we sort of need to get rid of this listener on the stream after the first time we have scheduled a request. So what can we do? Well, we can put this stream subscription, which we get out of the listen call, into a variable. So stream subscription will be its name, and we're going to store it. And now, whenever the connectivity result is not none actually, for the first time, we're just going to call stream subscription.cancel. And this way, after the first retry, this stream subscription, this closure, will never run again. Awesome, so let's put this all together, and just remember that if this is quite a lot for you to comprehend on the first try, you can always take a look at all of this code and also on the fully written tutorial from the link in the video description. Now let's go back to the Retry Interceptor, and we are going to add the final dio connectivity request retryer dependency. We're going to populate it through a constructor, and now we can use this request retryer whenever we should retry. So what are we gonna do here? We're going to do a try catch block, and inside the try block we are going to simply return request retryer dot schedule request retry and pass in the request options from the error object. So again, this is the failed request which we want to retry, and as you can see, we are returning the response back from this on error callback. And if some other exception happens from the request retryer, we are going to simply return the exception from this on error callback. So, for example, if some sort of a situation happened that we would get another socket exception inside the schedule request retry for some reason, that second socket exception would be returned as usual from the get request, and we would simply be able to catch it in the UI as usual. Actually, the second socket exception can really happen because the connectivity package does not put any guarantees that if the connectivity result is not none, that there is actually some sort of an internet connection. All it means is that the user is connected to a network, but as you know, the network is still present even if you plug out the WAN cable from your router. So your router can emit Wi-Fi signal, but that signal is actually leading nowhere, only to your local area network, not to the wide area network. So you need to keep that in mind. Connectivity package does not guarantee that you are actually connected to internet, to the World Wide Web, we could say. And now that we have implemented the interceptor and also the retryer, all we need to do is to jump back to main.dart and plug our interceptor to the DIO instance. And again, you can get this main.dart file from the written tutorial as a starter project. So all we need to do here is to grab our DIO instance, which we are instantiating a few lines above, and we're going to grab interceptors and add a new element to over there. Our interceptor is called Retry Connection Change Interceptor. We need to populate it with a request retryer. Oh, I did not make this parameter named. I probably should. So let's do that right now at required. Let's import it. And now we're golden. So we need to populate the request retryer with our DIO connectivity request retryer. And that in turn takes in a connectivity. Let's instantiate that, and also DIO. And of course, you would not do this manually in a real app. You would instead use some sort of a dependency injection system like injectable to populate these parameters of the constructor. And now we have introduced some sort of an error to our project. I'm not sure why. Whoa, I forgot about what? Oh, there should not be the semicolon. That's kind of obvious. But anyway, we've just added the interceptor, and when I hot restart the app now, open up the emulator, we request data. When we have internet, it works as expected. But when we go into airplane mode and now request data, yeah, we still get the socket exception. That's not an issue though. That's only happening because we are catching uncaught exception in VS Code, and for some reason VS Code thinks that this exception is not caught. But anyway, when we hop through this, when we continue in the execution of the code and now come back to our emulator, we can see that the circle is spinning. But what's different now is that when we disable airplane mode, you will stop this circle from spinning, and actually the request will be retried successfully. And as you can see, that's precisely what happened. So we know our code works nicely. To go through this tutorial at your own pace once again, and to also get all of the code, check out the written tutorial from the link in the description. And you have just learned how to create retry on connection change interceptor using the DIO client for HTTP in Flutter. And I am absolutely certain that doing something like this will enhance the user experience of your apps, because automatic retrying is, in my opinion, much better than prompting the user to press a button to retry the request himself or herself. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, and link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. And over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, where we tackle important topics for Flutter developers, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you with implementing this kind of an interceptor, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.